Hey savvy people, it's Savvy Nick here. Today I plan on continuing with the Python tutorial and learning about Python. In the last stream I learned about how to define functions, make function calls, pass arguments, and we were also able to default some arguments and practice creating a prime number series function that tells you if a number is prime or not. So today I plan on doing much of the same, continuing on with the Python tutorial on python.org, which I have here in front of me. And we'll be continuing on chapter 4. So let me actually get to chapter 4 here. I think we were right around defining functions. Here, more on defining functions. We did this part. Let's see. Oh, hey, Sai. Nice to see you. Hope you're doing well. Functions, here we go. So I believe we were off on the keyword arguments from last time. And one thing I did decide to do is create a another prime number series function, and kind of just wanted to compare it against what we did last time. So I'll bring that up actually. Let me get Visual Studio launched. All right. And I already created another file here, so I'm going to open that file. It's called prime_num. And in prime_num here, what I did is you can see I have two functions. So this here is kind of the original function that we created through the Python tutorial. Let me make this bigger. And then the other function here I created based on what I thought would be a little quicker, and it turned out not to be. Matsu, nice to see you too. Glad you're here and present. I appreciate you watching. So I was thinking if we could go through less iterations, which I thought this would, that we would save some time, but it didn't turn out to work so well. So I'll show you these two. So this is the original here, and I just did a simple time function. I actually imported time here, and then what I could do is call time on the beginning before we go through the for loop, and then time again. If I subtract the 2 times it by 1,000, I think I get milliseconds here. So this is, or maybe seconds, I don't know, probably seconds in decimal form. So let's just run this real quick just to show you how many numbers to test. Well, let's just test 1,000 numbers. And it looks like I have something messed up. Of course I do. Let's see. Trace back in range n2 to some number num. Okay. Well, for whatever reason, I don't have these fixed. Not sure why. Let's try that again. So we'll put in 1,000 and another error. Let's see. String object cannot be interpreted as an integer. Well, thank you. And where is that at? Line 32. So the problem's here. And what am I input? What was I thinking? I think you can cast it as an integer here. Let's try that. All right, that works. So it took around 138 milliseconds to go ahead and run this second script. And let's try the other script that I created. Well, other function, I shouldn't be saying scripts. I was just working on some bash shell scripting, so I keep calling things scripts. I mean functions. So I'm going to run 1,000 with mine. And actually, it was quicker than I thought it would be. All right. Interesting. So the prime number function that I created is a little quicker. What I want to do is print out, let's see if it's actually doing everything correctly. So I'll go over this in just a moment just to kind of explain what I did for mine versus the one that the tutorial spit out and told us to do. I don't know if you guys are interested in this or not, but I thought it was pretty interesting. I know last time we went through the prime number series and tried finding prime numbers, and I was trying to figure out how I could make it a little quicker, but I didn't think I was able to, but it looks like I was actually. So here we actually get an entire list spit out with all of the prime numbers. So you can see like 2, 3, 5, 7. Those are all prime numbers. If they're not prime numbers, I just labeled them false here. So the reason I thought this would take a little longer, instead of just printing it out to a screen, we had to access an element inside of a list and then update that element. So I thought that was going to take a little longer than it does. So as you can see, this is what we get. Of course, there's 1,000, so there's a lot of information to look at, but it spits out all the prime numbers for us and neatly packages them into one list that we can use and do whatever we want with. All right, and before we go over that function that I created, is anyone watching the SpaceX rocket launch? That's pretty exciting today. I'm actually going to watch it a little later. I'm pretty excited to see it. If you are excited, feel free to post in that chat. Let me know. All right, and so back to this function. Before we move on to the tutorial, what I did was I just simply asked, hey, user, what do you want? How many iterations do you want to run through to check the prime numbers within those iterations? And then I just initialize this list to a list that has nothing in it. Awesome. Glad to hear it, Sai. Yeah, I mean, it bloated, sure. You can call it bloated, but it gets the job done faster. You don't have to use a list, I guess, if you don't want to. The reason I just use a list is to be able to save the information for whatever, but we could set it equal to whatever. I mean, false is just a Boolean, I assume, so basically it's just a 0 or 1, which we could also just put 0 or 1 in here too. It doesn't matter. I just thought it made more sense to me if it's not a prime number, it's false. Otherwise, it's the prime number. But in order to continue on, we're going to print out just that we're working on it. That way, if we don't print out the list, they know we're working on it. We can remove that, of course. And then we start our first iteration where we just kind of go over and append to our list a bunch of numbers. So we start from 0 and go all the way up to whatever the number that the user inputted. We create that list, and then we'll work on that list. Hey there, Jimmy. Nice to see you. All right, so iterating over the list. Now we're going to check and see what numbers inside that list are prime. So we're basically going from that 0 to 1,000 mark because I put in 1,000. And we don't want to really start iterating over the list until we reach the second element because, well, there's no reason to. Then what we're going to do is just print out list inside of those first two elements, 0 and 1, and then we'll continue with 2 because in order to use this function down here, the modulus operator will have to start from 2 because if you do mod 1, that's really not going to happen. Yeah, right, Sai, yeah. There's definitely ways to improve it. I'm sure you can think of 100 ways. Feel free to post them if you want. I don't mind improving. So now, since we go through this, so basically we just go through the entire 1000 set in this first for loop. And we define that, we define a variable called j that's going to loop through all 1000. And while we loop through all 1000, what we'll do is we're going to check with the second for loop wherever we're currently on. So let's say j, and we'll call it 2 right now. We'll do 2, and then we'll do a new k integer so we can check the next element inside the list and then mod that with j, so the current number that we're working with. So if it's 2, we'll do basically 3 mod 2, and if that's equal to 0, well then that means that it's not a prime number or false. Otherwise, we'll say, we'll keep looping through, and if we already see that the list in the k+1 position, the next position in the list, is not equal to false, then we should check it. Otherwise, if it's already equal to false, there's no reason to check it. It's a prime number. Yeah, I guess it did. I got a little excited from the last one. I mean, I had enough of the tools to use in order to actually come up with a better solution, in my opinion. So I went ahead and just did it, just to show you how quickly you can kind of escalate this. What I'll do is, of course, I'm going to go back and learn more about Python here in a moment. I just wanted to show you this. I can post it if you'd like, so you can look through it. But the only real efficiency here is the fact that we're looking ahead and we're making sure that, wow, that's loud. Sorry about that. There's someone outside clearly mowing. Hopefully they pass here soon. So, like I said, I can go ahead and post this, and the only reason it's really more efficient is because it's looking ahead and checking if we've already checked that number, and if we have, forget checking that number, let's just move on. All right, so now what we're really interested in, let's go ahead, start a new file, and continue on programming here with the tutorial. Let me save this real quick. And I will call this lesson5.py. We'll put this in the corner here so we can look at both sides. Let's see. If you're new and stopping by to watch a stream today, make sure to subscribe below and hit that notification bell for future streams. My plan here is to go over this the last section of the fourth chapter. One thing I want to show you is I was on the main website here of python.org, and I found something a little interesting, at least in my opinion. I think this right here is wrong. Specifically, what they're doing here is they say they have these 3 strings defined. They're calling that list fruits. And then they create another list called loud fruits, and they print that list out, right? So does anyone else see what they got wrong here? I'll give you a moment. Also, if you're still with me and you haven't hit that like button, please make sure to do so. It really does help me out. All right, so the little issue here that they have, or at least I think they have, you can agree or disagree with me here, but they have fruits called out, right? That's what they call this list with an S. And then right here they call fruit.upper. I don't think this would work. I don't know how you call an upper function on something that doesn't exist called fruit. So then let's move on to chapter 4.7 here. All right, so functions can call using keyword arguments in the form keyword arg equal value. For instance, let's use the following. No, that was close of you, Jimmy, but I think they just called out the wrong list. Instead of calling it fruit, or fruits, they just said fruit here. All right, so hopefully you can still hear me here. I tried adjusting the volume because it's getting pretty wild out there. All right, so back to this keyword arguments value. All right, so what are we doing? Defining a function, and then printing a bunch of stuff here. Well, I think we actually did this last time, so I think I went ahead and printed this out and just kind of checked what would happen with arguments that you pass in. Either you can overwrite the argument by passing in your own, or it's going to default to whatever you say up here, just like it has in the like if you don't pass in a state, then a stiff is going to be the default, and so on and so forth. All right, Jimmy, see you later. Have a good one. So I'm not going to go through this right here because we've already done this. Let's keep it going instead. So yeah, so they're just showing you the different ways we can supply an argument. So if you do parrot 1000, you're just passing in 1000 into voltage. If you do parrot voltage equals 1000, then you're specifying the specific keyword where you want to send 1000 to. So here you do two keywords, so you can pass in voltage, whatever this number is, I think it's 1,000,000, and then you do an action called voom, so you're passing capital voom in, or all caps voom, into an action. So here is also, this is pretty cool. So now they're reversing the roles here. So they're specifically saying, even though this is the first argument, it will automatically find which one it needs to go to because you specified it needs to be the action. It doesn't actually have to be in order, I assume. So this is kind of cool. Let's go ahead and give this a shot real quick just to make sure that is a true statement. Let me see. Maybe we can just copy and test this out. Paste. Let's make sure it runs. There we go. Okay. And now we'll call that function with right here. Paste that in. And look at that. So let's see what comes out. So we called parrot action voom voltage 1 million. So this parrot wouldn't action, so this parrot wouldn't voom if you put 1 million volts through it. All right. So it's as we expected. You can specify arguments by actually calling their name out and then setting them to something. They don't have to be in order because voltage does show up in the argument list much earlier than action, but you can specify specifically which one you want to use. That's pretty cool. Can't do that in like C and C++, so that's something new that I have not seen before, so it's very nice. Makes things a little easier. I don't know necessarily why you might use it, because now you won't like to keep, I like to keep things in order anyway. All right. Three positional arguments. So this is just saying this is based on position. We're not specifying a keyword. And then this is one positional and one that's a keyword. Nice one, Matsu. Yeah, I keep looking back at that stream a little bit. So if I cut in and out a little bit, I'm just trying to. I keep focusing on the stream, the other stream going on. There's like 500,000 people watching now. That's wild, isn't it? 500,000 people. Last time, what was it? Last Thursday when they were trying to launch, whatever day that was. I saw it got up to like 1.9 million people live streaming that SpaceX launch. It's pretty exciting. I'm very excited. It's going to happen here in a few hours. I guess they're going to launch. Hopefully the weather permits this time. All right, moving on here. So they're just telling us some of the ones that are kind of invalid here. Let's see. So parrot, just calling parrot without specifying any arguments. I guess that's invalid because it expects at least voltage. It doesn't have a default for voltage. Here, non-keyword argument after a keyword argument. Non-keyword argument after parrot voltage equal to 5, and then I don't see why this one is wrong, but that's why we can try it out. So let me just try that. Run that. Okay. Positional argument follows a keyword argument. Gotcha. So you can't have a positional argument following a keyword argument. You must always have a keyword versus a positional. That's interesting. Okay. So you either choose one or the other. You can't get both. All right. And duplicate value for the same argument. Okay. That makes sense. So you can't duplicate, and you're specifying some kind of an argument that doesn't exist. That makes complete sense too. So let's move on. And in here we have a definition of a function A that does nothing, passes, and then a function where we pass in 0 and then pass in A equals 0. So you can't redefine. We already learned about that right up here. So yeah, like we would think, you get a error out. I think they're just showing us what would happen if you went ahead and made a call to the same, you reinitialized an argument twice. So that's a no-no. Don't do that. Moving on. All So this is kind of new. Definition. Cheese shop. Kind, arguments, keywords. Print. Do you have any kind? Question mark. All out for arguments. Print arg. Print 40. Okay. This, it could be called like this. Remember, it's very runny, sir. It's really very runny, sir. Shopkeeper. Client, sketch. And of course it would print. Do you have any? Okay, the first argument. I'm sorry, we're all out of Limburger. So it's just going to use kind again. And then for arg in arguments, print arg. It's very runny, sir. So it's going to print out this. And then I assume this. And then for keywords and keywords. Okay. Interesting. I think this is just showing us that we can supply multiple arguments inside of an argument that we pass into a function. That's nice to know. So special parameters. By default. Function position. A function definition may look. All right. Positional or keyword, positional only, keyword only. Interesting. So you can even define inside of a function whether or not you want to allow the user to only use positional arguments, positional or keyword only. So in keyword only, they would have to do kwd1 equal to something, kwd2 equal to something. Here they could do either or. They could say position or kwd equal to something, or just pass in an argument. And here they would only be able to pass in an argument and then only relate to the position that they or where only the position where the argument aligns. So if they had arg1, comma arg2, that's all that's getting passed in. Aritza, I don't know about that. I'm still struggling on some of these new, like this right here. This is pretty cool that you can do this. So you can force a user to have to do supply arguments in some type of a matter. That's pretty unique. I haven't seen that yet in any other programming language that I've messed with. So, but slowly but surely we're learning, and we're learning together. So I'm happy about that. Let me just check this. What's going on with the space launch? SpaceX launch, I mean. It looks like they're not doing much. All right, I'll keep this going here. I'm hoping to go ahead and finish up this fourth chapter here, if we can get away with that. There isn't too much, I think. Okay, so it says if by default, if the division symbol or forward slash or the asterisk isn't present, then the arguments can be passed in as a function, as a position or as a keyword. And we kind of saw that earlier, so no big surprise there. Oh, Aritza, I don't think it's canceled today. They're trying to relaunch it today, actually. So I think they got the stream going. If you want to go check that out, I think they got that live. Unless I haven't been listening. Unless they canceled today's because of weather too. I believe they canceled the one on, I think it was Thursday. I believe they canceled that one because of weather. Yeah, I was watching that too. There were so many people watching that. All right. So positional only, we already talked about this. Keyword only, we already talked about this. Let's move on to function examples. Consider the following example function definitions paying close attention to the / and asterisk. So we have the standard arg, then we have an arg with the /, then we have an asterisk with the arg, and then we have position only, standard, keyword only. The first function definition, standard arg, the most familiar form, places no restrictions, so you have no restrictions here. You can either specify a keyword or position up here. Hey there, Snaith. Nice to see you. Glad you're joining in on it. Yeah, it must have just been an old tweet. But if you're not checking it out, I got it streaming on the side here. Saravana. That's funny. Yeah. Well, thanks for joining and chatting with us. So let's see. Continuing here. Yeah. So they showed us. They're just showing us the different types that we can use. So this is a positional argument only. You can only specify an argument, not a keyword. And if you do it this way, you can only specify a keyword. Otherwise, you can combine everything together. They showed us that up top, so we're not going to go through this again. Let's keep going. So they just keep showing us various different ways of supplying arguments and restricting the user from supplying certain types of arguments. Let's keep this going. What else we have? Finally, consider this function definition, which has a potential collision between the positional argument name and keywords, which has name as a key. All right. Define a function called foo. They have two different arguments here. They return name and keywords. Okay. There's no possible call that will return true as keyword name. Will always bind to the first parameter, for example. Foo got multiple values for a argument name. Okay, so that's why. So you put in name and you return name, and then that also exists within this function, and now it's got two names that collide together. Yeah, I'd say that most of their stream, I have no clue what they're talking about, but it's pretty cool to watch, especially when it takes off, right? Now I gotta take a look. What are they doing? Looks like they're crowding around something, getting ready to go in, maybe? I don't know what they're doing there. Either way, pretty cool. All right, back to this. Yeah, so same here. That's a problem because you pass in one for name, and then you define name :2. So this looks like JSON here, if I'm not mistaken. Yeah, definitely looks like JSON. I'm assuming that this is a big part of Python later in the game, but we'll see. All right. So here it says, since we're only allowing positional arguments, since it's using positional arguments, now the name can be used to return name because there's no ambiguity. It doesn't care which one you're specifying name for. It knows exactly you specified it for position 1 or position 2. All right, Aritza, thanks for joining. Hope to see you in another one. All right, so recapping, they're going to go through everything we just went through, so I think we're comfortable with that. We're getting pretty close here. Don't have too much to go through. And if you're still with me, go ahead and hit that like button. It really does help me out. I appreciate it if you do. And let's see. Finally and least frequently used to specify a function that can call with arbitrary number of arguments. Okay. Whoa, variadic. That's a big word. That's a unique way to call it too, variadic. Normally, that's good. Okay. Sure. So all they do here is do a concatenate function, which it shows you how powerful this is. All it does is, yeah, I guess use some type of a function here to separate, join. I don't know. I'm just guessing sep. I don't know. But it joins commands together. Oh, into sep. Okay, sep's a variable. Take sep, and there's a dot join function on it. And then those arguments get passed into that join function, and it just joins them together with the default separator. Okay, so this is a join function with a separator, and the separator that they pass in is a is that a // and then they pass in whatever strings that they want, and those get concatenated together. Cool. And then the next one is the unpack arguments list. So this just shows you that you can pass in more than one argument into an argument definition. So multiple arguments here. The reverse situation appears. Okay, normal call with separate arguments. Yep. Call with arguments unpacked from a list. Sure. Sure. Yeah, so they're just passing in a list instead of passing in separate arguments. Easy enough. Let's keep going. Voltage, state, D, voltage. Yeah. So the key here is to pay attention to the commas because they pass in a voltage, a state, and that state has what seems like a string, right? And then Action also has a string. Well, this is much like, it's like they passed in a full JSON string. Lambda expressions. All right, let's see what this is. Lambda keyword, lambda A, B. All right. They define a make incrementer, n, and they return a lambda x colon x plus n. F make incrementer 42. Interesting. To return a function. All right, the above example uses a lambda expression to return a function. Another use to pass a small function in an argument. Okay. So the lambda operator, it can allow you to pass in and out functions. That's pretty powerful. So we have, you can see there's multiple this is a little tricky here. We might just have to do something like this here. Let's give that a shot. All right. Paste that in. Going to get rid of this up top. And let's see if we can run that. Yeah, of course, we need the let's see if that works. Pairs. So I'm going to print pairs. See what we get out of that. All right. Yeah. 4, 4, 1, 1, 3, 3, 2, 2. So let's see what's happening here. So pairs is originally, whoop, make this bigger. So pairs is originally a list, and that list contains list contains 1, 1, 2, 2, 3, 3, 4, 4. And then we sort the pairs. Gotcha. So instead of, what we're doing is we take these in and then we want to sort them backwards. So 4, 3, 2, 1. And we have pairs.sort key lambda pair colon pair 1. So each of these, is that a function? I guess I'm not following this that well. It's a little confusing how they've explained it. Let me see if they got anything else there. Not really. The above example uses another use is to pass a small function as an argument. All right, so this is a small function, I assume. And they're being passed in as arguments. And that's a full list. So functions in a list. So 4 functions in a list. And then we take something called key. Since we're passing functions in, we could say lambda pair 1 pairs. Man, they need to explain this a little better. That's a little confusing. I'll have to come back to that and kind of look over a little bit and get a better understanding, because I don't think this does it justice. Probably need to look at this lambda keyword and really understand what's going on. Oh, okay, here. The function returns the sum of its two arguments. Okay. So lambda, they show us kind of here what's done. A, comma, B, A plus B. All right. That's not the same as what they're showing though, so whatever. Kind of all over the place there, but I'll have to look at that later. So documentation strings. Okay, first line. All right, so we have learned this before, thanks to one of the people following the stream, that we can put in double quotes, and 3 specifically, in order to comment multiple lines out. So they have the 3 double quotes and the 3 double quotes, and anything in between those is something that does not get ran. If you want to do a single line to get rid of it, you just have to put a hashtag in front. So we've already learned about this a little bit. I'm not going to worry about it or harp on it. Function annotations. Okay. All right. Definition of f, ham string, egg string equals eggs, string print annotations. So f spam, they say f spam. Okay. So annotations become, all right, ham class is a string, return class is a string, eggs class is a string. So this must tell you what the arguments are or are expecting. Arguments spam eggs. Gotcha. Return ham and eggs. So the ham became a... So this looks like it's defining ham as a string, I assume. Eggs is a string, and the default is eggs, and that's all. I don't know what this part means. It's a class of strings. That's a wild one too. Let me reread this. Oh. I got a lot going on here in one little function. I'll have to take a look at this again later. All right, coding style. So now we talk about coding style. Most languages formatted different styles, readable, make it easy. Tremendous for that. So always use 4 space indentation and no tabs. So you can set up tabs to be 4 spaces, much like is done here in Visual Studio Code. So if I were to, let's say, tab over, this is technically 4 spaces, and you can see that denoted by the 4 dots here. So by default, Visual Studio Code's pretty nice, and it does that for you. If you hit a tab, it's going to go ahead and put 4 spaces in for you. Not an actual tab character. So wrap lines so that they don't exceed 79 characters. So the magic number is 79 characters. Don't go longer than that. Use blank lines to separate functions and classes, and larger blocks of code inside of functions. All right. When possible, we'll put comments on a line of their own. Use docstrings. Use spaces around operators and after commas, but not directly inside bracketing constructs. Okay. Name your classes and functions consistently. The convention is to use upper camel case for classes and lower case with underscores for functions and methods. Always use self as a name for the first method. Okay. Don't use fancy encodings. All right. Likewise, don't use non-ASCII characters. Makes sense. I actually like the fact that they did this for us. It gives us a little bit of understanding of how to actually format using Python. Now, of course, you don't have to abide by their rules, but what I've realized in the past, most programming languages don't actually give you recommendations on their own. They kind of leave it up to the people programming it. But this is definitely a very nice thing to have given to you from, Python directly, telling you, hey, these are the ways we do it. We suggest doing it that way. So it's definitely something to read over a few times to make sure that you're abiding by the rules. All right, well, I think that puts us through all of Chapter 4. Chapter 5 is next. I think this is probably a good stopping point for us today. We've been going at it for about 52 minutes or so. Thanks for following along, everyone who did. We got a lot done today and learned a lot about passing in arguments into functions. That's mainly what we learned about and how to unpack them. So I hope you enjoyed the stream of going through this tutorial on the python.org website. And I hope you join me next time. And next time I think we're getting into data structures actually, because I peeked ahead a little bit. And that's pretty exciting. Sai, it was good to have you. I'll see you next time. And before long, I think we'll be introduced to classes, I hope. That's going to be really exciting. Let me just take a look real quick at 5. Yep, 5 is data structures. All right. Well, thanks for watching, everyone. And I will catch you in the next one. Thank you, Matsu. Talk to you guys later. Bye.